Section 6.2 talks about a particular kind of discrete probability distribution called the binomial probability distribution. And I'm still in the slides. This is the Chapter 6 slides. And in the slides, it goes into some detail. It talks more in detail about what's a binomial experiment and has some practice exercises. It also has more details on steps you take in these kinds of problems. I'm going to go over a particular example, and I'll post this on our course site as well. But the thing to keep in mind with the binomial distribution is it's just a type of a discrete probability distribution. There are lots of different kinds of discrete probability distributions: geometric, Poisson, multinomial distribution. But the one that we'll focus on in our class is this binomial distribution. And a binomial distribution, it has certain characteristics that make it binomial. And these characteristics I've put in this document. They're also on the slides. But again, I'm going to go right to an example, and we'll talk about those characteristics and other parts of the problem as we go. So the example is that it's been estimated that 40% of the U.S. population is nearsighted. Suppose that I wish to conduct a study of the prevalence of nearsightedness among students at our college. I obtain a random sample of 20 students at our college and test each student for nearsightedness. So we'll want to keep this in mind, that 20 students, that's the sample size. And it'll also be important to remember this, that 40% overall of all U.S. people are nearsighted. Part A of this example says, why is this a binomial experiment? So this is a binomial experiment because, and there are 4 main reasons to look for. The first one is that the number of trials, and trials is just another way of saying your sample size, is fixed. It's fixed at 20. So when I do this experiment, I'm only selecting 20 students. Another reason that this is binomial is each of the trials are independent. And what that means is that every time I select a particular student from the college, that selection is not affected by the previous student that I picked. So if I pick student A, the next time I pick another student, that previous selection has no impact on who I choose next. The third reason that this is a binomial experiment is that for every student that is selected, there are only 2 mutually exclusive outcomes. In this case, either the student is nearsighted or is not nearsighted. And there are no other third options in this case. The fourth reason is that the probability of success, and by success in this case we mean finding a person who's nearsighted, the probability of that is going to be the same for every trial. And when saying trial, it's another way of saying for every selection. So every time I go to pick out a student, there's always going to be a 40% chance that that student will be nearsighted, because back in the problem, overall 40% of the U.S. population is nearsighted. So that P equals 40, that comes from the fact that 40% of the U.S. is nearsighted. So part B of this problem says, what's the probability that exactly 9 of the 20 students are nearsighted? So we would write this as P of 9, probability that 9 are nearsighted. There are different ways of calculating this probability. I'm going to go through 3 different ways of doing it. And when you do this on the homework or on the test, it doesn't really matter which way you prefer. You won't have to do all 3. You can choose the way that you prefer and just use that way. But for the sake of being complete, I'm going to show all the different ways so that you can choose. The first way, method 1, is to use the formula. There's a formula for calculating a binomial probability. This formula is in the slides, it's in the book. And for this question, the x is the number that we're asking about in the probability. We want to know what's the probability that exactly 9 of the 20 students. That 9 is the x. There's our x. The 20, of course, is our sample size, so that's the n. And then we'll just want to make a note that ultimately we'll need to use p, and the p is 0.40. And that's from the 40% who are nearsighted in the U.S. So here's our x, our n, the sample size, the p is 0.40. Put those right into the formula. So here in the formula, 20 is the n, C 9 times p, that's 0.40, so 0.40 to the x, which is 9, times 1 minus p, so that's 1 minus 0.40, to the n minus x, so 20 minus 9. So it takes some plugging in, but you plug in all those numbers. This is simplified a little bit. I subtracted this and got 0.60. I subtracted these two, I got 11. The rest of this you can put into the calculator as is. This right here, the 20C9, is called a combination. A combination is, there are a lot of applications of combinations, and in our class, for now, we won't go deeply into it, but you can either calculate this in your calculator directly. Most calculators have a button for this, or you can also calculate it using another separate formula, and that separate formula is this here. I'll write down the general formula right here. So it's kind of sideways there, but NCX, in general, NCX is equal to n factorial divided by x factorial times n minus x factorial. So that's what I have here. I've just plugged in the 20, the 9s, and done that. I simplified it. 20 minus 9 is 11. So it's 20 factorial divided by 9 factorial times 11 factorial. Work that out, multiply all these, and it comes out to 0.1597. So that's one way of calculating this probability, just using the formula. Another way to calculate this probability is to use a graphing calculator. So when your question for the probability is asking for the probability of an exact outcome, like exactly 9, for example, on the Casio, you'll want to use the function called BPD. If on the TI-83 or 84, you'll want to use the function called Binomial PDF. And so in these notes, I have the steps you would take on the Casio calculator, and also the steps you would take on the TI-83 and 84. Later on, if I am able to set up a good webcam, I'll try to make a video where I can show the calculator, but for now, these are the steps you would take on each one. But the main thing is, when you take these steps, you just want to still identify what's the x, what's the n, and what's the p. And once you know those, you can plug them in and it will solve it for you. So a third method is to use a table. There's a table in the book, and I'll provide a table for when you do the test. And you can go to the table and look up the exact values and get the probability. So we'll do that here. So if you want to look at the table, let's see if I have it here. And here's the table. It's table 3 in particular. And what you do is you look for the n. So here's n of 15. We want n of 20. So here's 20. And then next to it is the x. The x was 9 in this case. So here's the 9. And then up here are the values for p. And so our p here was 0.40. So we kind of line those all up. So 20, 9, go over to where the 0.40 is. And try to magnify this. And it's right here. There we go. Okay, so that's it, 0.1597. That's where the 20, the 9, and the 0.40, they line up. So if you're comfortable using a table, you can just look up that value. All right, in the next video, we'll go over the rest of this example.